Hi, in this video we will be seeing how we can perform face verification. In my previous video, we spoke about a general face biometric system and different components of face biometric system. Face verification or face identification is the last step in that process. In case if you have not seen that video, you can click the link on the top and watch it. But it's not mandatory to see this video. If you want to know the overall system, you can just watch that particular video. Now, face verification is basically verifying an identity of an person or a human based on the facial features. We are just making sure he is what he claims, right? So basically, what we do is we take the facial features and compare against a reference facial features. If you typically see an account opening, you will have an user picture over there. So when you log into a system, if you want to add additional security step of validating the identity, you can capture his face image, you can capture his image, extract the face, and then compare against the reference image to verify his identity. So that's what face verification is. We are going to see how we can perform face verification here. So I'm going to do is to compare faces. I'm going to use a data set from Kaggle. So I'll go there. Before that, I'm importing MTCNN as the first step for face verification is face detection. So basically, given a picture, given an image or a video or a live feed, you want to detect face in that particular feed. And once you have a face, you need to extract the face and then only you can compare. So for MTCNN is a face detection package that we are going to use. Then we are also using Keras VGG-Face, which is nothing but a pre-trained model for face feature extraction. It is trained against some 3.3 million images of 9,000 famous celebrities, right? So we are going to use it and we are going to kind of extract the features of some unseen images using this particular model. And I'm using Keras application because Keras VGG-Face is based on Keras and you need Keras application. It does not support tf.keras, and that's the reason I'm importing it over here. Now I'm going to access the data set from Kaggle, and for that what I'm going to do is I'm going to connect to Kaggle directly and pull the data set. Now if you go into your Kaggle account, if you go into the account settings, you can download a file called kaggle.json that has basically your API key to connect to Kaggle, right? So I have already done that. You can go to your Kaggle account and download it so that you can use the data set directly in Collab. So what I'm doing is first I'm making a directory .kaggle in my home folder. So basically I'm this tilde symbol is for home folder and I'm telling .kaggle. So because what happens when we try to authenticate to connect to Kaggle, it's going to look for kaggle.json file in the .kaggle folder. And once this folder is created, I am copying my kaggle.json. I have kept my kaggle.json in this location. You just replace it with whatever location you have kept it to this particular folder that we created on the top. And then what I'm doing is I'm kind of giving permission to this folder like 600, which is read and write permission. I am giving to this particular folder for the for basically the owner of this particular folder, right? So that's what I'm doing over here. So owner of this particular file. So once I have it, what I can do is I can go to Kaggle and I can list data sets to see what all data sets are there. And for that purpose, what I'm using is I'm using the Kaggle command. I'm telling data set list hyphen s faces. So I'm telling list all the data set that has faces in it. Data set name has faces in it. So when I once I run this, you can see like these are all the different data sets available in the Kaggle which has faces in it. Faces in it. There is Simpson hyphen faces, anim hyphen faces. There are animal faces and everything. For this particular purpose, I'm going to use this particular data set, Dan Becker 5 celebrity faces data set, right? So I'm just using those faces so that I can compare and basically see how verification is performed, right? I'm going to use the data set, and to download the data set, what I need to do is I need to execute this command. I'm telling Kaggle datasets download -d and that name that you saw on the top. So once I give this, it's going to directly download the data set over here. So the data set is already there. Maybe I downloaded it, so it's already there over here, right? So now the data set is there. Let me do an ls, and then you can see basically this data set is already there. And actually the basically the data folder is already also there. That means I've extracted it. So basically, if you run this command over here, it's going to say that the data set is already existing. Let me run this, and you can see basically it's already there. I what I can do is I can give a, that is replace all. So that's what I'm going to do over here. I'm going to give a, so it will replace all the file and it will again download it. Maybe I forgot to delete it. That's why it's already there. But now what I've done is I connected to Kaggle, pull the data set so that I can use this particular data set. Now, other option is you can go to Kaggle manually, download that particular file, upload in Collab or UI environment and use it. But there is an handy function to directly use the Kaggle dataset over here. Post that, what I'm going to do is I'm going to kind of import some of the packages. I am telling like I'm first importing the MTCNN. From the MTCNN package, I'm importing this MTCNN. MTCNN is nothing but multitask cascaded convolution neural network. It what it does is it performs face detection as well as key point detection, like eyes in the face, nose, and then the mouth starting and ending position in the face. Right, that's what MTCNN is. It is a pre-trained model, and it works pretty well on on large set of images. So the accuracy is pretty high. This is one of state of the art model for face detection. I'm importing CV, OpenCV over here so that I can load the image. I can perform some resizing the image and all. But you can use any other image processing package as well. I'm using NumPy. I'm using Keras VGG-Face. This is where what we are going to do is we are going to extract the key facial features to compare it with the reference image, right? And then I am basically importing the model itself. I'm importing the pre-processing function. I'm importing the VGG face model itself. I'm also importing SkyPy package cosine. So cosine is used to see the distance between two image. So you can use a Euclidean distance or cosine distance or anything. Accordingly, you can set your metrics, but I'm going to use a cosine distance over here. And these are the packages I am importing. Let me quickly run this. And then what I'm doing is I'm just I am from the extracted image on the top. I'm just reading one of the image. If you see the top extracted image, I have images from 5 celebrity, and these celebrities are Madonna, Mindy Kaling, Ben, sorry, like Ben Affleck, and then you have who is the Elton John and Jerry Seinfeld. Right, these are the different celebrities that are there. So I'm picking one of the image of Ben Affleck over here, and then I'm kind of putting it to image object, and then I'm displaying the image. I'm just using the collab CV2-im show patches package to display the image. Now CV2 also, OpenCV also adds its own show function that will not work on collab, and that's why collab has given this patches one. I'm using that and seeing this particular image. Now, this is the image that we are seeing. As I told you, the very first step is out of this image, we have to extract this particular face alone, right? And that's why I'm going to use the MTCNN package. Now, face detection is the key step to any face verification system. Now, this here it can be there can be multiple faces, there can be single faces. You want to extract the face first, and I'm going to do is extract face. For that, I'm using the MTCNN package. It gives I'm just assigning to a detector object, and I'm telling detector.detect faces and passing the image I created on the top. Now, once I run this, I'm going to get all the faces in the image. But in this case, I have only one face in this image. So I'm getting the coordinates of the face. So basically, it tells the 20, 35, 75, 88 is the X, Y, and width and height coordinate of that particular face. So that I can extract it. It's telling me the confidence interval that is 99% confident. That's a face. The key points are the other attribute it gives. Where is the left eye? Where is the right eye? Nose, left side of the mouth, right side of the mouth. But for us, the key thing I'm going to use it only the face here in this particular program. I don't need the other attributes, right? So to get the face, what to create to kind of draw the bounding box, what I'm doing is I'm creating a function that will create a bounding box on the face. So I'm using the same thing. I'm telling detector.detect faces. I'm using it again, but this time putting it inside the function. And you saw here, this outputs a JSON like top. And from this, I am picking the box over here, right? That's what I'm telling. From this faces object, I'm picking the box and I'm getting the bounding box. and then I'm drawing a rectangle on the face. I'm telling my image input image that I'm passing is the actual image, and the bounding box location is this is the x and y, this is the width and height coordinate, and then I'm returning the image object. So now if I run this function and if I tell the CV image show, then basically you can see it has correctly detected the face over here. I just need to extract this face, right? And similarly, what I can do is I can check for a few other images as well. I'm going to go check for one more image, and this time the image is like of Madonna, right? So once I run this, it's going to extract the bounding box, and then if you see over, this is the image, and exactly on the face it is drawing a bounding box. Now we have an now we exactly know the face location in the image. Now I need to extract only this part to do the face verification, right? So for that, what I'm going to do is I've created a function called extract face. In the extract face, what I'm doing is I'm passing an image file, and I am using like computer vision cv2.im read that image file, and then I'm telling the same detected.detect faces which I used on the top. I'm taking the box location which has the xy with the night coordinate, and then I'm defining my x1 y1 and x2 y2, and then what I'm telling, from the image object, just extract this y1 to y2 and x1 to x2, and then assign it to a new variable face boundary. So this will contain only the face object, right? And then I am resizing, I'm passing a resizing over here. I'm telling resize it to 224 by 224. So I am then take passing the face boundary and then resizing it. The reason I am resizing it to 224 by 224 is VGG face model is developed on images that are 224 by 224 size. So that's what I'm going doing over here. So I am next I'm using the cv2.resize, and then I am kind of resizing it and returning the image over here. Now what this will do is this will take that particular bounding box location, this will extract the face and give me only the face from the image. It will ignore all other part. So now I have this function. Let me call this extract face with the same Madonna image on the top that I showed you, and then let's see how it looks like. So if you see over here, it's giving me only the face object from here. If you go on the top, this is the face object. It has extracted only the face object, and now it has given me the face over here. Now I'm going to use one more image which I'm going to compare. This is also Madonna image, but this is a different image altogether. Here, if you see the Madonna is looking on the right hand side. Here, it's looking straight in the camera, right? So this is one more image. This is the face I have extracted. I'm going to extract one more face, and this time is going to be of Mindy Kaling, not Madonna. And let's see the face. Right, so in this case, if you this Mindy Kaling, and you can see like this is also facing the camera. So I have three faces now. This face and this face must match because both are Madonna's faces. And this, the first face or the second face, if I compare with this must not match, right? It's because this is completely separate person. I'm just showing this because the orientation, these two are straightly looking at the camera. The other one is looking at the right hand side, right? So let's see how it performs. Now, the very first thing I need to do is I got the face of the person. Now I need to extract features from the face. And what I'm going to do is I am going to extract the embedding from this particular face. And I have created a function called get embedding. I am passing the face object into this. Now I am using the VGG face model in this, which is nothing but a pre-trained model on faces. And it has been trained on 3.3 million faces of close to 9,000 odd celebrities. Right now, I am not going to train this model. You don't have to really train the model. You can train it, transfer learn it, but you can use the model as it is because it can easily understand face and it can generalize pretty well on unseen faces also. The only thing we need from this model is the embedding layer, right? And if you see over here, what I'm telling is I'm giving the VGG face. I am telling include top equal to false. That means I'm telling don't include the classification head, right? So what I will get is I will get one layer above the classification head, which is nothing but an embedding layer. The embedding is of 2048 size. In this, you can go and look at this particular VGG face information online, and you can see the entire model summary how it looks like. I'm telling the input shape is 224, 224, 3. It has three channels. And if you see, our image is also 224, 224. And that's the reason we resized. And I'm telling pooling is average, because what happens in this previous layer, embedding layer, you will have multiple channels or multiple filters over there. So I'm telling average the filter and give me the output, right? So here I'm taking a input face. I am just converting this face as an array. I'm calling the pre-process input function of VGG-Face. This is to pre-process the face. It's a predefined function there. And then I'm telling version equal to 2. Now, you must remember, if you are using ResNet 50, you must give version equal to 2. If you are not using version equal to 2, it will take version equal to 1, which is nothing but a VGG-16 model that it will use. Right, but I'm using the latest version 2 model, so I'm giving version equal to 2. And once I get the model object from there, I'm just passing the face object over here, and then I'm calling model.predict. The output for me from here will be a embedding vector, which is of 2048 size. It's just an array of 2048 embedding vector. So now this is how I get the embedding. Now I have the embedding. I need to compare similarity between two images, right? I'm going to compare similarity. Now what I'm going to do is I'm going to create one more function which will tell me get similarity. Now I'm going to pass two faces, right? So what will happen? I'm going to pass array of faces over here, maybe the Madonna first face and Madonna second face, and then I'm telling get embedding. So it will get the embedding of both the faces. This get embedding is the previous method we have, and I will get the embedding. And then I am calling the cosine distance function, passing the embedding 0 and embedding 1, and then I'm going to get a score. Now, if you take a cosine function, right, if both the embedding vector are closer, then the output will be closer to 0. If the both the embedding vector are kind of not alike, right, I'm passing an image of two different person, then the final cosine distance will be higher. It's a value between 0 to 1. The closer it is to 0, it's going to be a match. The more it is towards 1, it's not going to be a match, right? So I'm going to put a cutoff over here as 0.5, right? And what it's going to do is going to compare the cosine distance between two embedding vectors. And if it is less than or equal to zero point 0.5, that is closer to 0, that's what I told you, I'm telling face matched. And I'm also returning the score object, the actual score I got. In case if both are far away, not similar, then it will tell me face not matched, and it will still give me the score. So this is what it's going to do. It's going to take the embedding over here of two images and then return me whether it's matched or not. Right now, embedding is just like an final layer vector that model gives. If you want to know more about the how the embedding looks like, I can just put a print function over here and then do it for one. The other is going to be similar, right? So that way you can see the embedding over here. And let me run this again. Now next what I'm doing is I'm going to passing the faces. So here I'm passing two faces over here. If you see, both faces, data train Madonna and data validation Madonna. These are two different images of Madonna, right? And what I'm doing is I'm taking this two image, I'm calling the extract face function. So from these two images, it's going to extract the face. I'm again calling the base image, not the one I have extracted. So I'm calling what we downloaded from Kaggle. It will contain the entire image, right? We just need the face. So it's going to extract face and then create it's going to create a list, because I've given an kind of square bracket over here, and it will create a list of faces object over here. And then I'm calling the get similarity function and passing the faces. If you see, the get similarity function will return either face matched or face not matched. So since these both are Madonna, in this case the face must match, right? So let me run this and see whether the faces are matched and what is the score. Now, if you see over here, this is the embedding vector that I printed on the top. It's just nothing but an array of 2048 values, which is nothing but the last one but layer of the VGG face model. And then it says face matched, and the score was less than zero point 0.5, it is 0.44. So there was a good match in the face, right? Now, the next image I'm going to take is basically one is Madonna, and the second one is Mindy Kaling. So second phase is Mindy Kaling in this case, and the first is Madonna. So I'm going to call the same extract face and get similarity method and see how it looks like, right? So in this case, if you see over here, again, I'm getting embedding vector and tells face not matched and score as 0.64. Right, so basically, Mendy Kaling and Madonna are two different persons. That's why it's separate, right? And here, if you see, we are not trained any model at all, right? We are just using a predefined model. But this model was already trained on celebrity images, so high possibility it knows about um, it knows about Mindy Kaling, it knows about Madonna, it knows about other faces, right? Like all the celebrities. Now, what I'm going to do is I'm going to completely take different image, right? Rather, I'm going to take my image. So I'm going downloading two images. This image is nothing but if you go do a Google search by my name, you will see these two images. You can just right click and copy the link address and paste it over here. I'm going to take my two images, and one image is what I have on the top over here, which is in my Gmail account on the top. And I'm then going to download couple of images from India's Prime Minister Modi as well. And then I'm going to download an image of Amitabh, right? So these are the different images I'm downloading, and I'm going to see how my model performs on these images, whether it's able to find similarity or not. So now I have it. I'm going to iterate and show you how the incoming images look like. So what I'm doing is I have given some name for all these images over here. If you see iPhone O, Srivatsan 1, Modi and everything, right? So I have just created a list of all this object. I'm just iterating and I'm just like creating a bounding box on the face and then showing the image over here. Now, if you see, once it runs, you can see all the images that were there. So now let me go on the top. So this is like Modi's face. And similarly, if I go further on the top, just a minute, yeah, so this is my image. This is one of the image that I downloaded mine. There is one face and there is the second one. If you see, both are not similar, both are different face altogether, right? One is in well, looking at the camera, second is, yeah, slanting slightly, not completely away from the camera, but okay. This is like our prime minister, India's prime minister Modi image. And if you see, basically, even this image is, you are going to see, is going to be different over here. Just a minute, my somehow my scroll is not working. Let me try to. Okay, so you can see like this Amitabh Bachchan, right? And the top one again, you have Modi in a different pose altogether. There's also a different pose, right? So all are different images over here. So what I'm going to do is I'm going to run a similarity check on all this. The very first thing I'm going to do is compare my two faces, right? And see how close they are matching. So I'm doing the same thing. I'm first taking those images, I'm extracting the face from the image, and I'm doing a get similarity function, right? And now in this case, you can see like how close it is. It says face matched. It says like score is 0.35, which is less than zero point 0.5, right? And the next one, what I'm going to do is I'm going to compare myself with Amitabh to see like if I look like Amitabh Bachchan, right? So in this case, I'm doing the same thing and I'm going to run it. And the next one, what I'm going to do is I'm going to compare Modi's images. If here it says face not matched and it is 0.73, it is like way apart, right? So I know we look like Amitabh Bachchan. That's a different story. Now, next I'm going to compare two Modi faces, that is Modi 1 and Modi 2. I have three images of Modi. One has a long beard and other are like pretty much same. So it says face matched 0.25, score is less than zero point 0.5. Let me compare the first and third image in which he has a longer beard over there, right? So in this case, if you see, the face is still matched and it's 0.21. So it's not, it's even with all this noise and all, it is generalizing well on the faces, right? And finally, I'm going to run it along with Amitabh Bachchan, Modi and Amitabh Bachchan. They are no way in common except for the white bird, both of them are, and it says face not matched and it's 0.59. So what you can see is how easy it is to extract face with VGG-Face. You don't have to really train a model, but if you want, you can transfer learn and you can create as a classification model. In this case, what I'm doing is I'm just doing face verification. So face verifications, I'm doing one-on-one comparison. I have a reference image, I have an input image, I'm comparing. But when you're doing a face identification, that means one to many. You're taking one face and searching across all your database, right, and picking that one particular image. Now think about it. If you have a million images in your database, you need to write your data structures in such a way that it's very efficient in going and searching through that one particular image that matches most with your input image. So we will see that in a real world example when we start using it to build and project. We will see that. But for now, this is how you perform face verification. And you're just taking two images. You are just created a pipeline with all pre-trained models of detecting faces and then verifying the face. And that's about it in this video. Thank you very much.